I'm Tim Ventura, and we're joined today by Dr. Julia Mossbridge. Julia has a PhD in Communication Sciences and Disorders from Northwestern University, an MA in Neuroscience from UC San Francisco, and a BA with honors in neuroscience from Oberlin College. For the past 15 years, Julia has been studying the psychology, physiology, and physics of precognition and time travel. As an internationally renowned expert on prediction, she's addressed audiences around the world in her work shaping the field of time travel, and recently became the president of the Society for Scientific Exploration, an organization devoted to supporting emerging scientific fields. She's taught intensives on precognitive forecasting to executives at Google X and the Vail Symposium, invented and patented the Choice Compass app, and currently pursues her mental and informational time travel and precognition research as funded by the Robert Wood Johnson and Bial Foundations. She joins us today to discuss her research into cognitive neuroscience, predictive abilities, and the mysteries of the human mind. So Julia, welcome. Welcome. Let's start out with your background. You are a subject matter expert in psionics and remote viewing, and you've really invested yourself in this topic after getting a master's, PhD, and doing postgraduate work in mainstream cognitive neuroscience. So what inspired you to get into this area of research?
I think about time differently than most people. So most people are looking for an answer to that question in the past. So what past experience pushed me into the field? But actually, I believe I was called from the future towards that field. So
there you go. Okay, actually, that's a great answer. Well, you know, it's interesting that you mentioned that. And I'm going off my questions a little bit, but you know, most of us do have a really linear stream of the way that we look at time, right? You know, past, present, future, and then we're always moving towards the future. But reading Scientific American and other magazines, there are many different ways to look at time. You know, I mean, you've got closed time-like loops in physics. You've also got, I'd read about this card deck view of time. There was a physicist who was promoting that, where he said every now is basically its own universe, and we're moving through a series of different universes. So looking at time differently is something that some people do, you know, and it's valid, especially from a scientific perspective.
Yeah, it's valid, I think, for sure, from a scientific perspective. The two examples you just cited, the most popular sort of known individuals who are promoting them are Julian Barber with the cards in the deck, or the pieces of toast in the bread, or whatever you want to call it, and the guy who helped out with Interstellar. Oh yes, it'll come to me. He's at Caltech. Anyway,
Kip Thorne.
Kip Thorne, thank you.
Yeah.
I wanted to say Kit, but I knew it wasn't Kit. So yeah, but yeah, he's the one. He's interested in these closed time-like curves, and so those are two really extremely different and potentially integratable ideas in the world of physics. In the world of perception, so how human beings perceive time. Let's just leave it at human beings for now. It's also reasonable to think about different ways. So we're used to this sort of linear approach, and the future is unknown and the past cannot be changed. And here we are in the now, and the now is special because we experience it as special because I can see you in the now, you can see me in the now, but I can't see you 5 minutes ago and I can't see you in the future. So it's special, right? Those are all valid ways of thinking about time too. And I think that much of my work so far has been about trying to integrate these different physical views with these perceptual views. So trying to understand how the stories we tell ourselves about what's going on in time in our conscious awareness have anything to do at all with what we can understand of the physics of time. And it's tricky because there isn't really a privileged now in physics. So Einstein came out with special theory of relativity, basically saying there's nothing that's actually simultaneous for everyone, for every observer. So that indicates that there's no privileged now, which kind of breaks apart the whole thing, right? And that was a disruption that happened 100 years ago, and we're still dealing with it conceptually, because regardless of what Einstein said, we still have this experience of a privilege now. So to me, the question of time gets to the question of consciousness, right? What are we conscious of versus what are we not conscious of? Is it the case that we're conscious of only a story about time, and what we're not conscious of is the physical reality of how time works? If that's the case, it would be fun to get behind, not only fun, but useful in terms of prediction, to get behind what we're conscious of and into what we're not conscious of, to really understand sort of the landscape of time. So
yeah.
So that's kind of, I think, where it's going.
Well, no, it is interesting. I mean, time, again, the way that we evolved, right? We had this very linear view of it, and we all tend to look at it the same way. But then you get into, you'd almost call them exceptions, right? Or these edge cases, right? And like one of those is the GPS satellites. They have to do relativistic corrections on those because the signal attenuates because they're higher up in the gravity well. Time moves a little differently. And, you know, and then you run into all of these little changes with different things. Quantum mechanics is another one. And I know that you've explored this, where a lot of these equations in quantum mechanics, they work forwards in time. They also work backwards in time. And, you know, so yeah, it's one of those things that seems so normal to us until you start to really look at it, and then it really doesn't make any sense at all.
Well, so just to be a little more precise, the classical equations of physics, almost all of them are time reversible. The quantum mechanical equations seem to be loosey-goosey in time until you get to what people can call, but don't necessarily believe in, the collapse of the wave function. So like when a particle is absorbed, for instance, let's say an electron or a photon is absorbed, that sort of changes, it seems to change the time symmetry or the loosey-goosiness of the equations. And so interesting interpretations of quantum mechanics that take that into account are interpretations like the two-state vector formalism interpretation, or the transactional interpretation, where there's this idea that in some way the past and the future have to agree on what's happening in the now. So that the privilege of the now is that it's sort of where the agreement has to happen, but that it's shaped by these boundary conditions of the past and the future. And that's very much how it feels to me. And I started about 12 years ago, when I was starting work in the physiology of human prediction of unpredictable or seemingly unpredictable events, sort of unconscious prediction of unpredictable events. I started also thinking about an experiment I wanted to do in physics involving photons. Do you want me to talk about that now?
Yes, I would love to transition onto that. Yes, because as we talked about earlier, we're on a schedule and we're going way off track, which is awesome, because I love talking about your perception of time. But yeah, you did do an experiment with photons, and then that also relates to consciousness and our perception of time. Could you tell me a little bit about that?
Yeah, so I got excited. Thanks. I was going there anyway, so I just wanted to get permission. Thank you. So I got excited about this idea that, you know, every time I would hear about the double slit experiment, and I'm going to assume that the people who are watching this know what the double slit experiment is, but if you don't, just go to YouTube and find out, watch a video, it'll take 5 minutes. So in the double slit experiment, usually it's described with a single particle at a time that's going through these slits. And it goes through both slits at once. And that's the interpretation of why you get an interference pattern at the end of this sort of tube. And because it's interfering with itself. And so that's kind of weird. It's non-local in space, right? So the particle is kind of two places at once. So that's weird. And I always thought of it as, are we sure that's what's happening? Because it could also be non-local in time, which is equally weird. So what would that mean? That would mean that a particle, for instance, that's not yet emitted. So a particle that's emitted in the future is going to interfere with one that has just been emitted. So there's two kinds of particles sort of in this tube, one that has just been emitted from a light bulb, and one that in the future will be emitted. And they do their interference in some kind of spooky way, and then they cause an interference pattern. And so what would that suggest? that would suggest that you could actually do an experiment to test this. And this is what I was excited about. That would suggest that in the first few, I don't know, minutes of an experiment, where you turn on the lamp and you turn on the detector in a simple single slit photon setup, then in the first few minutes, you should see a differentiation of how many photons are absorbed in the detector based on how long the experiment is going to be in the future. So let's say everything is at least 1 minute long. Every experiment you're doing is at least 1 minute long, but a random number generator that's truly random, so a quantum-based random number generator, is used to determine how long this light will be on in this detector after the first minute. So maybe it shuts off after the first minute, or maybe it goes on for another 9 minutes, or maybe it goes on for another 20 minutes. In those, for instance, those 3 cases, the prediction is you would see a difference, because in the future, you're going to have many more photons to interact at the beginning, and those photons are actually going to stimulate emission of further photons. I'm using a photomultiplier, so in the photomultiplier. And so what that means is in that first minute, the photons are going to tell you what's going to happen in the future, even though it shouldn't be predictable. So that's what I started testing. And thanks to Dean Radin, I was working at the Institute of Noetic Sciences at the time. He had a single photon double slit set up, and I tried it, and I did see a significant difference. And then I went to a meeting at the Science of Consciousness, and I spoke with Roger Penrose, who was interested in developing his quantum gravity collapse ideas, and specifically interested in retrocausality. And he asked me, what's the best evidence for retrocausality? I said, I think it's a photon thing, although there's human stuff, but that's harder. And so I told him about the photon thing, and he said, you should use a single slit, because why would you use 2 slits just because that's what you're trying to describe? It's simpler to interpret a single slit because all you're looking at number of photons, but all you're looking at is number of photons. And genius, and of course he is a genius. And so I changed, and then I replicated that and put that out in the world. And now I found a person at UC Berkeley named Winthrop Williams who replicated it again. And now I've been replicating it some more. So it keeps happening that that first chunk of time with the photons is predictive of the future duration of the experiment, as if you've sent a message back in time and it worked. So that's exciting.
Yeah. Well, so now I want to take a jump to people, and actually this works perfectly because you are one of the world's leading experts on remote viewing in a scientific manner, right? And so not only are you a remote viewing subject matter expert, you're also a trainer for remote viewing. So I'm wondering, could you tell me a little bit about remote viewing? And this I think bridges us from the science physics part of things to more of the human consciousness part of things, right?
Right. So so let's assume that our story of time and space that we experience is false. So let's just start there. So that opens up a lot of possibilities for the kind of information you can get if you know that that story is a construct that it works really well, but it doesn't describe reality completely. So it has it's parallel to reality, but doesn't describe it completely. So look into Donald Hoffman for his interface theory of perception to sort of think about this kind of distinction between what we experience and how it's related to the physical world. So now, with that assumption, how can we train ourselves, our minds, to access the information that's there for us that's not limited to our local time and space? And it looks like from 1972 to 1995 in what ended up being called the Stargate program, the US military and intelligence communities did just that. So they figured out, based on Ingo Swann, who's an artist, coming to them and saying, yeah, I can do this. I'll train people to do this. He made up a training method, right? But it was a method that once people got into the habit of doing it, it was almost like a ritual, a technical ritual. Once people got into the habit of doing the steps, it sort of, I don't want to say hypnotized, but it got them into a place where they could access what's underneath this line of consciousness in a way that was helpful. I won't say eminently helpful, because the way the subconscious works is very different from the way the conscious mind works, right? And so under the line, the information comes up like, I'm seeing a frog, and the frog is burping, and the burping is in Morse code, and this is what the Morse code is. I mean, it is not straightforward a lot of the time, right? It is often jumbled and not what you want, which is a billboard with the answer to the question that you're asking. You know, how long is the war in Ukraine going to ask? Here's a billboard that has the answer, and 15 remote viewers are all saying the same. They're showing you the same billboard. It's not like that. It's not like regular intelligence. So that's part of why the program was ended in 1995. There were problems with the way the program was administered, which I would like to fix because we know more. But the final report that ended up killing the program that the CIA asked Congress to commission said multiple times. So the biggest significant effect here is precognitive remote viewing. So precognition seems to work really well. Over and over again. That was in the report.
You know, it's interesting. My understanding, and I could be mistaken about this, right? But I think all of us, and I know there are lots of scientific answers for why, you know, nothing special is supposed to be happening. But I think all of us have had events in our lives, especially precognitive, right? In my family, that's common. I've met so many people who have had things, and it's like, you know, psychology, I think, would say that your mind adjusts the memories of the past so they fit the current experience, you know, and lots of nice explanations for it. But I would say that many people have had information from the future transmitted to the past, and this would be the time travel, information from distant areas that they couldn't know that they've received. And I think all of us have had flashes of that at some point, whether or not we like to admit that to ourselves. But what interests me about remote viewing was, it's like, okay, so how do you take this thing that's for most people really like random and rare, and it's a flash, and how do you turn that into more of a scientific discipline? And if I remember right, one of the keys to it was you have a team of these people and you basically throw away the data that doesn't match. Is that kind of accurate?
Well, that's too simple because, but let's talk about sort of a nice protocol for that. So I'm working with Carmen Medina right now, who's spent more than 30 years in an executive level positions and analysis at the CIA. And she and I are thinking about ways to bring precognitive remote viewing back to the intelligence community in ways that are supportive and actually use the value of precognitive remote viewing to shift people's minds and kind of de-bias them and move people more into intuition as they do their important analysis work. So the way I think things should go might be different from the way other people think things should go. But I'm going to tell you my thoughts, which are that you need to create a team that has remote viewers who have different capacities. So some people are really good at viewing other human beings and what their internal motivations or feelings are. So that's really valuable in the intelligence space, right? Some people are really good at viewing locations, super valuable. Some people are really good at predicting tensions, like tensions between countries, valuable. Some people are really good at remote viewing interesting technologies that could be useful, or breakdowns in technologies that could happen in the future. So you get a variety of skills, and that's what you're going to screen for. Of course, you screen for accuracy, right? And you screen for the ability, the ease with which accuracy, I think, should be translated as the ease with which an analyst who knows the viewer can interpret their data, right? So there's always an interpretation process. And if the analyst knows the viewer and has worked with the viewer, then you can work on accuracy with known targets before you get to the unknown targets that are actually used, right? The other thing I think that's important is, sure, concordance, but concordance within those different kind of skill sets. So if one person's really good at technology, they're not gonna, and the question is about emotional interaction between two world leaders, maybe you don't even use that person in that particular precognitive remote viewing, right?
Oh, that's an excellent point, because everyone has different backgrounds and information they bring to it. And so if you're remote viewing, that makes sense. If you're remote viewing technical stuff and you have someone with no technical information, they're not going to be very helpful.
Yeah, sometimes they are, right? So sometimes you bring them in anyway, because sometimes they give you interesting insights that you hadn't thought of. So this is the other piece of the problem, is the question that an analyst or a tasker asks isn't always the question that needs to be answered. And very skilled precognitive remote viewers will look at the question, they'll say, that's not actually the real question that you want answered. And they'll answer another question. And if you're a skilled analyst, if a bunch of viewers are doing this, you can start to go. So let me give you an example. I was doing a remote viewing team. I was leading a remote viewing team for a missing person. And I was tasking on, where is that person now? And the viewers kept giving me back information that couldn't possibly be true, but consistently across viewers. It's frustrating. So I talked with the family, and I just talked to the family about using their intuition, and I used my intuition, and we all kind of figured out together that the person was in a particular area on this island. And that turned out to be correct. But what it turned out 2 weeks later, what the viewers were answering is the better question, which is, where will this person be found? Right? That's a much better question for a missing person than, where is this person now? Because it doesn't really matter where they are now. It matters where they're going to be found in the future, right? So the subconscious mind is kind of smarter than this conscious mind that thinks it knows the right question. And so there's a lot of art to it. But for sure, you got to keep your viewers trained in questions that have firm answers. I just don't think those firm answers need to be describe this building, describe that building, et cetera. They can be a variety of firm answers about people, places, things.
Now, in terms of remote viewing through time, are there boundaries or limits to how far out you can go or should go? I mean, it would seem perceptually, the further out in time you go, the less familiar things are. Have you noticed any issues with that? Or
this is a sticky question, because there is so in a closed time, like, I'm looking at the light on my ceiling, which looks like a closed time like curve graph.
The only reason I mention that is, like, okay, the world that we live in now, things are moving so rapidly, right? And so, if you took one of these CIA remote viewers from the 1970s and you asked them to remote view 2020, half the stuff that we have wouldn't make sense. I mean, they wouldn't know what an iPhone is. They might be, it's some kind of handheld computer. It looks like someone's doing something on it, so I don't know. That was one of the...
Actually, I think that's not quite true. So my concern was more an ethical concern. If we have, every time I wanted to show you something on the board, which is why I unplugged my headphones. If every time you observe something, you also affect it, then there's an ethical question of how far out you want to observe, because what futures are you bringing into possibility, right? So that's a more ethical question. In other words, by observing which things are more positive, could you make that future come to pass? So would you want to train viewers? So one of the things I study is positive affect and feelings of love, and how that supports accuracy in remote viewing. And if you wanted to train viewers in that space, that's very different than a space of, looking for negative things. And so how does that impact things? But I just wanted to show you sort of a sense of how it might be for, like, I was in a project with Stephen Schwartz, who was looking at the year 2060 and asking a bunch of skilled remote viewers to describe 2060, right? That's pretty far out.
Yeah, I would love to read that. Do you have that? I would love to. In fact, if you have that report, I'd love to link to that.
Yeah, I don't think he's done with the project. So I think he's still analyzing it, but definitely worth talking about. But so one of the things that you might see, like if I'm a viewer, can you hear me from there?
Yeah. There's a little echo, but you sound great.
Okay. So if I'm a viewer on that project, I might have this experience of, like, okay, well, so there's this round, this is like a cross section. That's like a cross section of some kind of a bowl-shaped thing, and it's got these hatchings. And the hatchings are what integrated between the dimensions. So there's this is like trans-dimensional sort of, I don't know why I draw this star, but some kind of trans-dimensional system that integrates sort of the 3D, 4D material world with the fifth dimension. And this is used for energy. So all that information can just come to you without you calling it like a Gulaboo or whatever it's going to be called in the future, right? Like, so you could do the same thing with an iPhone back in the 70s. There's this black square, but sometimes it's really colorful and people press it and different things happen. They won't be able to call it an iPhone, but they'll be able to name the purpose of it.
Oh,
Does
okay.
that make sense?
No, that does make sense. That does make sense. So you're saying they can describe things, they just, yeah, they wouldn't necessarily be able to use the terminology. So you can
Right.
look forward and backward and things along those lines. Now,
Yeah, it doesn't mean it's correct because it's going to take 40 years to find out if that's correct, right?
yeah, and by the time you find out, it probably won't matter. You know, they say, well, it's an iPhone, who cares? You know, but
Yeah, right.
yeah. This idea of time travel, this is a big concept, especially when it's viewed through this subjective lens of human consciousness, you know. So it's exciting that you're able to talk with that about me. Now, I wanted to mention you're co-organizing the invitation-only Quantum Time Machines Conference in July. That's upcoming at the University of San Diego. And so you're going to be focusing on a lot of these ideas there, right? Can you tell me a little
Yeah,
bit about this event?
sorry, yeah. So I'm working with Daniel Sheehan, who's in the physics department as well at University of San Diego. And he has, gosh, he alone, without me, has created the quantum retrocausation meetings, which is a meeting for a subdivision of AAAS, the American Academy for the Advancement of Science. And that he's done that, I believe, every third year or something since maybe 2011. And I have been to, I think, 2 of those, and I've really enjoyed them. And this time, last summer, I said to him, so I want to make a time travel conference where we do things differently. So we're going to actually have a working groups where we're going to have small groups that are working on different aspects of the problem of building a basically an informational time travel process. And I don't want to call it a machine because it might be a process, but in any case, sending information to the past from the future. And he's like, well, that's bold. And I'm like, yes, exactly. So as usual. So he knows me well, and he said, great, let's do it together.
Oh, okay. And so that, see, what this, you've described this twice. And so I want to mention this now. I had heard, this was many years ago, about a ring laser experiment for time travel. The ring laser experiment, this idea, this premise was that once you turn this on, you could send information back and forward in time. I know science fiction has used this as a plot device, right? And so you can time travel, but only for the extent that this thing is on. So with your experiment, it reminds me of that. You're saying, we're going to send information back to the past, I guess. And that would be a little bit different than because I know other people have tried experiments where they've said, we want to receive something from the future, but no one has specified when. What you're saying is we specifically want to send something back to the past, which may make one of those past experiments work, right?
Yeah, it's the same thing, right? So receiving information from the future and sending information to the past are 2 sides of that handshake. And you can't have one without the other, right? You can't be successful in sending a message if it's not received, and you can't be successful receiving if it's not sent. So I'm just focusing on we got to learn how to do this part backwards if we're going to get to the goal of the other part forwards.
Yeah, I think it's an interesting. You gave me a quote. This was last year. For some reason, maybe it was the way you said it, but I was talking to you about. I don't remember what it was. And you just said to me, Tim, time and space are not what you think. And I was like, that's for some reason that stuck in my head, I guess. And I remember what it was. We were talking about space and long distances of space travel and things like that. And it was in the context of even without time travel, even with normal time and space, the way that we all perceive it, once you start to look at these massive scales of the universe, right? I mean, you look at the scale of evolution and you look at the scale, how long it takes to get into other galaxies and stuff like that. Once you start to stretch those scales out, what we think of as time and space doesn't make much sense anymore.
Well, I guess I'm to the point where I don't feel like it made much sense in the first place. But that's probably because I've been looking at it so differently for a while. But yeah, absolutely. These scales, and also these scales make you think, if you were going to invent time travel, the way in science fiction time travel is depicted as like a person travels a time, H.G. Wells' time machine. A person goes way into the future, or a person goes way into the past, or an object. But as we start to recognize the value of information and how information is aligned and shapes the universe, it seems to me that information is what we're really talking about. At some, at some point, the species is going to get it, that we don't need to have spaceships traveling through, billions of light years. The information just has to show up if that's the goal, right? We are so tied to this belief that we currently have that the physical is that every other species is going to be based in the primacy of the physical. And I think the primacy of consciousness is and information is where we're moving, and start to understand things a lot. I think we'll start to understand things a lot better as we move in that direction.
Well, and actually, that's probably a great topic for our remaining few minutes. Is consciousness again? I think this is an excellent issue. I think the human race is just starting to get into this. I think the internet is really enabling that, right? But for instance, in terms of science conferences, once upon a time, it used to be everybody gets on jet planes and they get in their cars and they meet up at a location and they hear someone speak, and people still do that, right? Especially, the old timers are still pushing for that. They're like, we have to be here, we have to meet. And I'm like, well, why? Unless you're physically touching someone, is there something that makes that better than Zoom? And the advantage of Zoom is you could do 10 conferences in that same span of time, right? So, it's the information versus the physicality of it. And we see that in our lives right now. So what you're saying is, we can see that, I guess, even more so from a consciousness perspective.
I think so. And I guess when I listened to you say that about the conferences, I thought, oh, I love hugging people. And so I don't want to underplay the value of being in the body. Like when consciousness is constrained to the body during life, that's really valuable for learning a lot and noticing what's inside ourselves and the way internally we can use our bodies to access altered states and different information. In other words, if you treat your body like an antenna for consciousness and for information, then you see it as almost this sacred tool to connect with the universe. So it's very mystical, but I feel like that is a way of treating the body that is respectful of its actual value and power, and its relationship to information and consciousness. In other words, I don't want to say that bodies aren't important and we can all just upload ourselves to computers, because there's something really valuable about the finite nature of life and about what it means to be in a human body and how human bodies are constructed, beautifully and wonderfully made. I mean,
yeah, and there are a lot of unknowns also, right? Like you mentioned Roger Penrose earlier. So I did an interview with Stuart Hamroff, and I know that you know about the microtubules part of this, but it was, his premise was, we look at neurons in the brain as, science looks at neurons as kind of the seat of consciousness. Okay, well, so you've got, the dendrites, they're sending out signals, and, that gives us a limited number of connections. And computer science says, if we can replicate these with a neural network, you can upload the mind. And he's saying, well, no, there are these quantum processes that are also at play. And if that's the case, then the actual computing capacity of the human mind could be several orders of magnitude higher, And so I guess the worry would be, if we do get too mechanistic with consciousness, what happens when the next Stuart Hamroff comes around and says, oh, and guess what? You guys missed this too, and this was really important because this is where the soul lives. And so,
well, and that's how it'll be. I mean, so that's how science, the great thing about science is it's full of mistakes, right? It's just human beings trying to figure stuff out, right? And trying to use the scientific method, which is beautiful, to have this conversation with nature, to try to understand, like, wait, when you do this, are you trying to do that? And what does this mean? And how can we use this, etc.? That to me is just golden. That's beautiful. That's a gift that we can use to understand the universe, and we will fail consistently, but also get better and better. at describing what's going on. Like it's like nature's startup, right? Like fail early and often and continue to fail. But we're moving in this direction of learning and understanding. And that's just, I mean, how much cooler could things be? So I think that's really important. But one of the pieces that culturally is kind of missing, at least in the United States, in terms of the world of science, is an awareness that these emerging sciences, so these sciences that aren't part of the mainstream yet, like precognition, I don't care how much data I produce and how rigorous my data are, it's not accepted in the mainstream yet. You know, people either think I'm, you know, making some kind of mental mistake or logical mistake or methodological mistake, even though these experiments are very easy to run, or fraudulent, maybe, you know. So these kind of accusations or beliefs come from not understanding that emerging science lives in a different world than mainstream science. So science goes, like Thomas Kuhn wrote about, says everything more than I could say about the structure of scientific revolutions. But what we know from what he's thinking about and what other people have experienced is that people think nature's like this. And then someone comes along and says, I have evidence that there's a little blip here. And people say, no, you're just not seeing the right thing. No, there's still a blip, you know, centuries go by or decades. I still see a blip. And then all of a sudden these people are like, you know, there is a blip there, but it's just anomalous. It's just a little anomaly. It doesn't really have any impact. Like whatever, there's a blip. We'll just put things into our equations to deal with the blip. And then another generation goes by and they go, turns out the blip is like, you know, the belly button of the universe. Like it's where it all came from. It tells the whole story. It solves all these problems. Right. And so emerging sciences and technologies have always been a real focus of mine, because to me, they're what is being called into the future to become mainstream.
Yeah.
So that's why I'm excited about the SSC. And I'm really excited. We're going to do a big overhaul of the organization, the Society for Scientific Exploration, and try to make it a national center for information about these emerging sciences like UAPs, psychic abilities, survival of consciousness after death, remote healing and remote influencing, these kind of, the science of mystical experiences. These kinds of areas need the attention and nurturing of almost like a nest.
Yeah.
And so I'm kind of wanting to create a nest for them so that they can be looked at differently and then nurtured till they get to the point where they're ready to fly.
Well, and I think that's incredibly valuable too, because what you're trying to do is apply scientific rigor to things that we think we know there's something there, but it's been very difficult to pin anything down, right? And your experiment with photons is one example of that, where you're saying, okay, let's take this idea and try and apply some rigor to it, and you know, and that way we can start to kind of build a framework around it and say, this is what we, what was it, the known knowns versus the known unknowns and all of those things. So
exactly.
Well, Julia, thank you again. Thank you again for your time. I cannot thank you enough. It's been wonderful. And we will come back. You have so much more to talk about if you're open to it. I would love to have you back on, and we'll take things from there. So
that sounds great. Thanks, Tim.
Thanks again.